Welcome everyone. Happy holidays. Thanks for coming out. I'm Tom Stabline. How many new people do we have tonight? Great. There were 29 signed up. So we have 1,000 members, and I know there's 105 we let in and then capped it because we didn't want 105 people in here. You don't want 105 people in here. So happy that we're getting adding to the group. We're gonna have to think of some really interesting things to do next year to spice things up a little bit. I mentioned last week we went up to campus and did a couple events there last year, which were pretty cool. We put a lot more people up there, and got a couple faculty members and at the University of South Florida. Sorry, I'm a faculty member at the University of South Florida, and I sponsor this event with Dana back in the back. Hi, Dana. And that's all we really do is sponsor, buy the food, and then I use a few minutes to just talk about our master's program because that allows us to buy the food. We have a master's of science in data analytics, basically for working professionals. So if you're thinking about, analytics is going to be your career, or you're already in analytics and thinking, I need to, refresh my skills or expand my understanding of the field, then our program is designed for you, and it's live instruction, so online. So your Saturday and Sundays for a few hours, and you get your master's program. How many people are in the program or have been in the program? Usually we have a number. So just Riley, so anybody can ask Riley about how that experience is going. But so anyhow, really happy to have Sri here tonight to talk about data engineering, data platforming. He actually has a degree. He has the same degree from USF. Many moons ago, he was telling me, I think the third cohort that ever went through the program.
I don't want to sound old, but yeah.
You are. That's all right. I'm excited about tonight. I also, on the side, have launched a company that kicks off tomorrow night as our first planning session, hired developers already. And I expect to be able to automate the project management function inside of companies. So I've worked at 2 large companies, and that's kind of the space I was in, and leveraging the capability of Gen AI and LLMs, and how we will depend upon the accuracy, right, of data and all the underlying systems, which we can never depend on, right? It becomes more important because when we're going to interpret that data and especially unstructured data, and then store it in these vector databases, and then from there reason from it, like the quality of that data becomes just even more important. So I'm excited to hear what he has to say tonight, and I don't want to take any more of your time. Are there any questions about the meetup? We'll have a little, Dana, we have a raffle tonight? All right, we'll have a raffle at the end, those tickets. Any questions before we get started tonight? All right. It's all yours.
All right. How is the sound? Is it good, or should I use some? Hello? Hello? Better? So I don't need this? Okay, perfect. There goes the technology. Okay. All right. Thanks everyone for coming. Thanks, Tom, for having me here. Thanks, Dana, for organizing everything. Let's make it interactive. It's actually, it'll be cool. More questions, some more insights come up. This is my own phrase. There's no good quality analytics without good quality data. So we'll talk a lot about, data platform at scale. I don't know how deep or wide I need to go. So if any questions, feel free to stop me. A brief introduction about myself. I'm currently leading the data engineering here at SurveyMonkey. Anyone heard of SurveyMonkey? There you go. Then I'm at the right company. Okay, good. And prior to that, I worked for Nielsen, which is, again, Nielsen, I'm assuming most of you have heard, is a 100% data company. I met a few Nielsen folks here. I have a great affinity to Nielsen because it's an amazing company to work for. I don't get paid to say that. I just say. And then I also did my master's at USF, focused on data analytics. In fact, I traveled across the globe from India to US, mainly to focus on data analytics. It's something close to my heart. So I've been in data for a while. I tell my wife I married data before I married her. Sometimes she doesn't like it. You can reach out to me on LinkedIn. I also have I recently started a mentorship program through TopNet. I talk all things data, resume reviews, coaching, anything that I can help. I'm just trying to figure out how to give back to the community. Okay. So we'll talk about what SurveyMonkey does. A little bit about the company. We'll talk a lot about data platform. What are the different components that make up a data platform? How do you run it in the Snowflake ecosystem? How do you run it in the AWS ecosystem? And then I'll double click a little bit about Snowflake because that's one topic that Tom also said would interest. We have great interest to the folks here. We'll also talk about the future state of data analytics, where things are going, right, than where it is today. Okay, who's SurveyMonkey? We the platform for surveys and forms. We have a lot of Fortune 500 companies as our customers. Whenever someone thinks about surveys, they think SurveyMonkey. I'm not going to read all the statistics there. It's been around since 1999, and the amount of data that we collect just keeps growing at a massive scale. So in terms of what types of feedback that people can use the surveys for, you want customer feedback, employee feedback, you run an employee 360 type of program. It's a great tool to use. Market research, product development. If someone's launching a new brand, and let's say I'm launching Coca-Cola in Costa Rica, how is the brand going to be received by the particular demographics and region, right? Those are some of the analytics you can run through surveys from the SurveyMonkey platform. By the way, I do have a lot of SurveyMonkey goodies there at the back, so feel free to grab on the way out some cool stuff. There's some USB chargers. That's the most popular. Okay. Data platform. So before I dive into data platform about end-to-end, I want to define data engineering. Right? How many of you are in data engineering? Anyone here? Okay. So if it's a repeat, please pardon me. Data engineering is development, implementation, maintenance of systems and processes, full end-to-end, all the way from raw data to process data and analytics, which is then consumed by downstream systems. Obviously, there's a lot of data management, security, data operations, and orchestration. Orchestration is where it's the workflows, right? You have to build the workflows. It's a good intersection of all these different areas. So if someone asked me, I'm in software engineering, can I get into data engineering? I would say absolutely yes, because there's a lot of overlap. Then you're just dealing more with data and not just the code all the time, right? And what does the data engineer do? They manage the full data engineering lifecycle from getting the data from source all the way to the destination. There's a book called Fundamentals of Data Engineering. It's a good book for me to recommend if you want to get into data engineering. Try to understand what it's all about. It's a pretty good book. Okay, what are this is a typical data platform, right? You start all the way from the left to right. That's how you read it. This is called the data pipeline. You start all the way from the source, and then you have the consumption layer, which is the analytics, right? That's all the predictives and LLMs and whatnot. Typically, the data sources that exist, you get product data, like someone's using your product, right? Let's say SurveyMonkey in our case. Someone's using the SurveyMonkey product, how they are utilizing the product, what features they are using in the product. So that is product data. It usually comes from transaction systems like a SQL Server or a MySQL and whatnot. And then you also have enterprise applications like Salesforce, because you get all sales related data from Salesforce. You have Google Analytics, all the web traffic and web analytics data you get from Google Analytics. From Workday, you can get the employee-related data or HR-related data, right? So these are different types of sources that I'm talking about. And then streaming data, all event-driven data. Hey, someone clicked something, they went to the next page, they did this. It's a lot of event tracking systems. So that's what they call as log data or streaming. So that is another source of data. And then typical flat files. At Nielsen, we used to process like massive flat files. These could be unstructured or semi-structured or structured. Anyone can define what structured is? It's more of rows and columns, right? That's a structured data. Unstructured.
Key-value pairs.
JSON is more like a semi-structured because you still have the key value pair.
Oh, text or video or.
Yeah, it could be a video or just in an MP3 or MP4, right? Those are unstructured. So these are the different types of sources that can feed into your data platform. Right? At Nielsen, we used to get a lot of data from providers like Comcast or other cable TV providers. That's a lot of data, and there's also streaming data coming from Sling or whatnot. Right? It's massive amounts of data, and then usually you get it into a landing zone, right? So we get all the raw data in one place. Now you figure out like how to process it. Where do I put the data from there? Okay, so there are two types of data stores that exist, right? One is a data lake or a data warehouse. A data lake is more of, okay, I can keep all types of data, unstructured, semi-structured, structured. But a structured format, you typically go into a data warehouse, okay? Two types of methodologies exist on how I'm going to process the data. One is like an ELT. Can anyone define what ELT is? Yeah, so extract, load, and transform. So in a data lake, because I just want to load the data first, and then I'll figure out whether I need to transform it or not. Okay, and at Nielsen again, like we are like massive data lake. Data warehouse is okay. It's a lot more expensive to maintain because I have more structured data in there. So I put a double arrow between data lake and data warehouse. Anyone can guess why that is?
Have some processes the right to the data warehouse.
Yeah, you could do either way, right? You can take the data from data lake, process into the warehouse, or you can write back to the data lake, right? So a data lake use case, typically a lot of data scientists, who are okay with, who are happy operating in unstructured data format, they can go to the data lake. But if you go to structured data, a lot of people go to the data warehouse. Some companies use both for different use cases. Because sometimes data warehouse could be, again, as I said, it's more expensive it is to maintain, and it's also more expensive in terms of dollars itself. And then let's go to the right-hand side, analytics side, different types of analytics, right? A typical descriptive analytics, wherein you are like building Tableau dashboards, or you're running a lot of ad hoc analysis on the data. That falls under descriptive. You can also have custom applications that you build. You can build your own UI applications to consume the data. And predictive, of course, everyone knows about what predictive is. That you run machine learning models, all the LLMs, and all the things you can predict for the future outcomes based on historical data. That falls under predictive. And then destination. So, at SurveyMonkey, for example, we are sending data to third-party providers for some from additional processing on their end. So that falls under destinations. Any questions on this so far? Okay.
What is the bus app?
Which one?
The third-party bus app.
Business applications. Okay, like Salesforce, Marketo, Salesforce Marketing Cloud. Those could all be business applications. And then the workflow orchestration is what that pieces everything together. Okay, connecting the dots. So your workflow goes from, okay, I process A, then I go to B, then I go to C, then I go to D. That becomes your workflow orchestration layer, right? And then at the bottom, I have this bunch of undercurrents. I call it undercurrents or pillars. I have a separate slide in which I'm going to talk in great detail about it. We'll talk further there. Any questions on this before I move to the next one? So how does this same thing look in an AWS ecosystem, right? So this is on Amazon Web Services, right? I literally translated, okay, what's a traditional platform, typical platform look like, and what are the different services available on AWS for the same, right? In AWS, from an ingestion perspective, you have some services like Amazon EMR, which is Elastic MapReduce for processing like huge, real big data type of volume. And then you have the Spark, which is an in-memory engine. And Amazon has its own managed version of Spark, which can scale up and down, and it's easy to manage to process huge amounts of data. Or you have the traditional EC2, which is just a bunch of servers that you can run some small data applications on. Typically, S3 is the landing zone in the Amazon Web Services use case. And then for streaming data, there's a queue-based system like Kafka or Amazon Kinesis to process streaming data as it comes in. S3 is a big thing in AWS because that's where massive amounts of data goes in, and it's also cheaper compared to other storage options. When it comes to transformation, again, you can run Spark, you can run Lambda. Lambda is like the serverless version of compute that AWS provides. Highly scalable. It doesn't need like an actual server to manage. The cost is strictly based on how long the compute is running. AWS Glue, the Glue is an option for, it's a no code or some code based integration tool provided by AWS to run your transformations on. And your data lake typically is S3 in AWS ecosystem. So you can ask me a question. Okay, I have the raw data also in S3, and I have a data lake also in S3. The only thing is you clean the data a lot more before it lands in data lake because you want to make it ready for consumption. You will not put dirty data in a data lake, for example. Dirty data may reside in your landing zone, and then you will create another S3 bucket in order to put the process data in. And then Redshift is the cloud data warehouse version from Amazon. I know at Nielsen we used to do a lot of Redshift, processing. So that's the structured data warehouse from AWS. And then DBT. Anyone heard of DBT? Perfect. So DBT again is a data build tool. It's a transformation tool which takes the traditional SQL way of coding and the software engineering best practices, wherein you can run CI/CD and DevOps type of methodologies on a transformation tool. For our teams at SurveyMonkey, it's been a game changer because they're able to truly test their code along with the data in a lower environment and run automated continuous integration for them to know whether the processing is going to fail or be successful. It's our developers' best friend right now. Okay, and then as far as analytics is concerned, AWS provides its own Amazon QuickSight, but there are also other tools like Tableau or Looker or Power BI that you can use for descriptive analytics. For predictive analytics, you have SageMaker, which is coming from, it's a managed service where you can build ML models and actually take it to production, offered by Amazon. Easier to use because it's truly managed in terms of compute. And then, of course, who can miss Python? Python is the best friend for data scientists, machine learning engineers, data engineers. Because it has a lot of friendly libraries, easy to consume libraries to process different types of things. Python has become more of a de facto in the data engineering or data space overall. Destinations, again, you asked about business applications. It could be HubSpot, Salesforce, whatnot, right? So Why would I have Salesforce as a source and a destination? Any guesses?
Writing back.
You are writing back because you're processing it within Snowflake because you get some type of raw data. You want to add some processing and write it back to Salesforce. One standard use case is this, right? Let's say I'm predicting the customer churn score. Okay, when will a customer going to churn? I get the actual sales data or opportunity data from Salesforce. Then I run my predictive algorithm on top of it, and then write the churn scores back to Salesforce so that our sales teams or our customer success teams, when they are looking at the data, they know, hey, I'm on the call with this customer. Guess what? There's 50% chance the customer is going to churn. Let me give them some extra TLC. Okay, right? So that's the beauty of putting the data to where the operations happen. If I ask the 800, say we have 800 people in sales in SurveyMonkey, right? Or maybe right now it's 400, something like that. It's a huge number. If you ask them to come back to Tableau to run their analytics, it's like this: hey, I'm already in my Salesforce system. Why would I go back to a different system to run my, run my insights or know about my customer? So the trend is provide the insights where business is running or doing their business, right? Because then there'll be more barriers to entry if they ask them to, go to 5 different systems to get data. As far as workflow orchestration is concerned, again, there are tons of options. Airflow, Amazon Airflow. So there are 2 versions. One is open source Airflow, and there's also an Amazon managed Airflow. This is the orchestrator. It just, essentially, I'm telling the workflow to say, hey, run A, run B, run C in a sequence or parallel and whatnot. So I call it like packaging the meal together. That's what Airflow does. Yes.
What about like pipes and streams and things that are just native inside of?
In Snowflake, the thing is, Airflow gives us more flexibility in terms of connecting the upstream system data to and then to downstream, because we get to control. The problem with Snowflake pipes and streams is like twofold. One is like I don't have complete control because from a data operations perspective, we want to get notifications when a job fails. Snowflake does not natively provide that. Like we integrate with PagerDuty to provide alerts when a job fails. Other thing is cost. So those are the 2 reasons that we haven't used in our system. We haven't done that. But I know some, if your pipeline is like small, you just have a couple of dependencies. It's okay to use the pipes and streams. For us, it's mainly for flexibility that we are going with Airflow. It gives us full control on what I need to execute next.
Are you doing that to, I get like getting the data from like, outside systems that you need to get into S3 and orchestrating that. But what about when things are just natively already sitting inside of?
I'm not following the question again.
So once you have the data in S3, there's other.
The same thing. We use Airflow for taking the data. Again, from S3, I want to load it into, let's say, Snowflake, or I want to load it into Redshift or whatever it is. You still use Airflow to run the full pipeline. And Airflow can also fire machine learning models as well, because everything is in the code. So you can literally like stitch everything together using Airflow or Daxter. Bunch of tools out there. Anything on this before I go?
Can I add to the gentleman?
Sure.
And there was also Event Bridge in Amazon. And step functions.
So yeah, again, step functions and event bridge, it did not give us as much flexibility as we needed that Airflow can provide. Because again, within the AWS ecosystem, like if you want to just completely be married to AWS ecosystem, you can use their own different things. But if you're using outside services and you want the flexibility, you want to go with a much more versatile tool. Okay, so everything that we saw before, right? The only thing I've changed here is the Snowflake becoming the cloud data warehouse in the middle. Okay, right? So you can still use dbt for transformation. You can still you can use Amazon S3 for landing, but for the structured data, like you're actually putting it in Snowflake. Now, I explicitly did not put data lake as a separate store here. Any guesses there?
Snowflake.
Because Snowflake can act like a data lake and a data warehouse. The reason is Snowflake is using S3 behind the scenes for as a storage. So you can provide a structured format to the data that is sitting on S3 by simply just loading it in Snowflake. It behaves the same way. So because Snowflake can process structured, unstructured, and semi-structured data, you can use it as a data lake and a data warehouse. I have a separate slide on Snowflake where I'm going to double click further. Sorry, you had a question?
I guess you just use Snowflake instead of Databricks. Or if you'd ever mentioned that.
So again, Databricks is the competitor to Snowflake. So Amazon version is Redshift. Snowflake has its own Snowflake version, and then there's a Databricks is a separate company. And then Microsoft Azure also has its own. So these are the four major, and also Google BigQuery. How can I forget Google BigQuery? So these are all like head to head. Snowflake and Databricks love each other so much that they had their summit on the exact same day.
Different.
So that the same person cannot attend both. So just saying. Yeah.
So I'm clear that the difference between the data warehouse and the data lake is that data lake is all unstructured data. Is that right?
Data lake, you can have any type of data, structured, semi-structured, unstructured. A cloud data warehouse typically has only structured data, but Snowflake actually extended it further, saying like, hey, I want the entire world to be married to my ecosystem when it comes to data. So once you are in Snowflake, I want to keep you in Snowflake. I will provide everything. You can use it as a data lake and a data warehouse. So that's why some of these ecosystems, once you get in, it's very difficult to get out, right? Moving from Redshift to Snowflake, Snowflake to Redshift, generally it's going to be like a lot more barriers to entry because Snowflake that's why Snowflake is creating an ecosystem wherein you can run your own machine learning. I'm also providing machine learning functions and algorithms. You can literally run machine learning where the data resides. Just like running a SQL on Snowflake, you can run a machine learning algorithm on Snowflake because data is right there. You don't have to take the data to somewhere else to run a machine learning model on it, right? So that's the type of capabilities that Snowflake is providing. Okay, so I haven't changed anything else. The only thing is I want to give a variation of, if you're not truly completely operating in AWS, and you're operating in Snowflake, this is where you go. So I can change the same thing to Databricks. The only thing is Databricks is all Spark based, right? It's a managed version of Spark. Okay, what is Spark? It's an in-memory computation engine. Okay, it's originally coming from Apache Spark, and then it's open source, and then Databricks made it more enterprise license, right? They made it more like, something I'm going to sell. I'm going to give compute clusters for you to run the Spark. And they also have a UI to run it and all that. So again, traditional Spark, it doesn't come with its own UI. Okay. Any other questions on this? Comments? Okay. Okay, so let's talk about the undercurrents or the different pillars, right? Because a pipeline just doesn't run by its own, right? So you need to have a solid data infrastructure. So what is a solid data infrastructure? How scalable it is? Okay, today I'm processing 10 million rows. Tomorrow I'm going to process 100 million rows, and day after 1 billion rows. So should I keep changing my data warehouse or keep changing my infrastructure just to support this? It may be very, very much cost prohibitive. So you want to create something that is scalable for future needs, right? Cost is something important. As an engineering leader, for me, like cost is always on top of my mind, right? So when it comes to Snowflake cost, or when it comes to like any other cloud cost, I should be aware of, okay, I'm coming up with a solution, but I should not be spending like millions and millions of dollars. So how do we run cost effectively? Infrastructure as code is very important because I need to be able to stand up clusters just with code. So that's where Airflow comes in, right? When I use Airflow, talk about flexibility, because it's API rich, I can fire API to do anything. I can write some Python code to, okay, bring up a compute cluster, shut down the compute cluster. All these things I can completely programmatically do. That's where the infrastructure as code comes into play. Isolated environments and CI/CD. So isolated environments is like, I need to make sure I have a dev environment versus staging versus production. How the different source and destinations are going to operate in each of these environments, so that whatever I test in lower environment is exactly what I should expect in production. Data modeling, right? Of course, in a structured format, I love dimension tables and fact tables to connect. So what are dimensions? This shows the attribute, like customer information. That's an attribute, right? That becomes a dimension. Customer sales becomes a metric, and that becomes a fact table, right? That's where the facts go. Right? And truly multi-dimensional model, you have like multiple facts sharing a dimension or multiple dimensions sharing a fact table. Data privacy, this is again one thing that keeps me awake at night is privacy and governance. This is important, right? Because I cannot have personal data available for everyone to access. We have a solid privacy team at SurveyMonkey. They keep me sane, right? Hey, what I should expose, what I should not expose, what specific contracts that we signed with customers exist that will prevent more exposure versus less exposure. So all these things are extremely important, right? So we constantly educate our teams on what does data privacy mean, right? So we cannot just process everything and make everything available to everyone. Retention policies, again, you cannot hold the data forever, right? You need to have a solid retention policy. Again, this is all data protection. GDPR is CCPA. Anyone can explain GDPR and CCPA?
GDPR is a general data protection legislation in the European Union that governs what can be retained for how long and right to be forgotten.
Exactly. And European privacy laws are like 10 times crazy than North America or whatever. So there it's like, we have some laws wherein someone says, okay, forget me from your site. Literally, we have to wipe them out completely from the system, right? We shouldn't be able to identify them at all. And then we do a lot of data anonymization. Sorry? We do a lot of data anonymization as well in terms of, okay, what email address? Okay, I cannot expose email address. I cannot expose phone number, things like that. Really interesting stuff and crazy stuff at the same time. Data observability. Now, this is a particular set of tools that are available in the market today. They're all artificial intelligence based. They will monitor your pipeline and automatically alert you if your data is missing the thresholds. So think about, let's say I'm building 1,000 tables and a lot of millions and billions of rows. You cannot add data quality check for every edge case. Okay, so this particular market is the data observability market is picking up big steam here because they're all machine learning based. They'll automatically learn your pipeline. They'll learn your tables. They'll learn your column data. And let's say that you always had a value of 100 in a column in a table every single day, and suddenly today it's 200. It's going to tell you that you have missed the threshold. Coming up. Hold that thought. Okay. Data lineage is important. I want to know what my source and destination is. So I have a raw data table. Then it goes through next layer of processing. Finally, it's going to consumption. how these tables are stitched together. That becomes a lineage. It's extremely critical because when I'm troubleshooting, engineers and analysts, they know it. Something is wrong with the data. Now, I don't know where the data came from. So I need to be able to go back to my start of the engine and see, okay, because this data was wrong is why this data is wrong. So to have a easy lineage end-to-end, like a tree structure, make our life easier in terms of troubleshooting any data issues. Data access and security. This goes very hand in hand with privacy. This is more about like who has access to what data and for how long. That's where retention comes into play. Role-based access control. Role-based, we do a lot of role-based masking. So we mask the data. If you are a person in customer success, you are not allowed to view this. But if you are a person in sales, you're allowed to do this. Because again, it goes through privacy and routed to us on what we need to govern. Data operations. For us to have a solid data pipeline that loads the data and for consumption, for consumers to consume every single day, solid data operation strategy is important. When something fails, how quickly are we getting alerted? How quickly are we jumping in to solve it? What are the tools that we are using to solve it? That's where observability comes into picture. So PagerDuty, Slack integrations, these tools come in extremely handy because you need to go notified. Snowpipe doesn't do it. Snowpipe streaming doesn't have an integration yet. I'm sure they're going to be coming up soon. Stakeholder management, right? Because if we all have SLAs. So for example, at Nielsen, we had SLA of 6 a.m. The data needs to be in front of the customer. For us, like we have a 4 a.m. Pacific SLA for the data. So the previous day's data should be processed before 4 a.m. the following day. So we have an SLA of 4 hours, right? So after midnight, literally by 4 hours, in the span of 4 hours, we should process the entire prior day's data. So that when our CEO logs in with a cup of coffee in the morning, he has everything. He has the data on how the business is doing. SLAs come into picture. So if something goes wrong, and if I get a PagerDuty alert, I'm jumping on to make sure I don't miss the SLA, right? But if I'm going to miss the SLA for some reason, communication comes into picture. So we need to make sure to alert the stakeholders. This is all important. Sounds like, okay, a lot of soft skills that are needed here, but it is absolutely needed. It is important. It's not just the technical aspect of it. Okay, so what is the future? Okay, I call it high velocity software as a service. There are plenty of tools. Just in the last 3 years, now there are at least 400 to 500 startups that have launched in data analytics space in the last 3 years. Massive, believe it or not. They have a tool for every solution. Okay, of course, we don't have unlimited budget, so you cannot go buy everything, right? For example, you asked about observability, right? Monte Carlo, Axel Data, Big Eye, these are some of the players in observability area. If you talk about data privacy and governance, there's a company called Big ID. So they are all about privacy and governance. There's something called reverse ETL. I don't know if I touched reverse ETL earlier. So reverse ETL is essentially you are writing data from the data warehouse to other business applications like Salesforce and whatnot, right? Either you can custom build that integration or there are tools like iTouch, sensors that automatically connect from your source to destination. In this case, the source is Snowflake or Redshift. It'll write the data back to destinations. Data science as a service. Now, may not be as promising for news for data scientists, but there are tools out there. You just need to feed the data and the feature set that it has a whole bunch of algorithms. You can pick random forest and this algorithm, that algorithm, it'll spit the output for you on what the predictive scores are. You don't even need to write code. Okay. These tools can replace 2 or 3 data scientists. There are some tools out there like abacus.ai, right?
Still have to know what it means.
What's that?
You still have to know what it means.
Yeah. So main thing that we still need a data scientist to actually figure out what feature sets are important to feed into the tool, but you don't have to write the algorithm, right? Tools write the algorithm for you and will give you the answer. There's data robot, data IQ, like there's tons and tons out there, okay? Anything I'm missing? So we talked Matillion, Fivetran. Fivetran is focused on bringing data into the data warehouse. Albyte has its own open source version, and there's also enterprise version. Matillion can do much more, like from ingestion and transformation. It can do it, but again, pretty expensive.
In this future, what would you say are the best skills that a data scientist or data engineer would have to be able to be better than these tools?
Tools cannot replace what the business wants. So that's where the data scientist comes into play, because you need to understand what the business problem you're trying to solve. Then translating that into the list of features that will give me the best predictive model is where the data scientist comes into play, right? Because
Understanding the output.
yeah, and you need to understand. So let's say some of these tools, right? Some of these tools have like 5 different algorithms that you can pick. Each of the algorithm will give a predictive score. You need to know exactly which one is the most accurate score based on what makes sense as the feature set that you fed into the tool, right? So that's where a data scientist comes into play. Where the tools helps us, like yeah, go ahead. Sorry.
Speaking of the business, I would also want you to understand when there is a choice of data to choose from, and there often is a choice of data to choose from. What the original intent was that data, and what is the meaning behind that data, and even when that data booked into its system that you're feeding from. Because if that data is variable, depending on instance of time or instance of issue or whatever that particular variable data can read, it's going to change what the output is. It's going to change what the meaning is. So the closer that the data scientist is to the actual function of the business and what those inputs are, and really fully understand, hey, this may have the exact same idea and terminology in this location as it does over here, but in what we're trying to accomplish, this is the one to choose from.
Yep.
And then downstream, I might have to vary from some other data over here, but knowing that, and those are the kinds of questions that in the past, when we did this manually, I would be asking very, 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 very detailed level. So for the younger ones, that would be.
So, I mean, the crap in, crap output, crap out makes a lot of sense, right? Because you need to understand what the fundamental problem, and you may be picking feature sets that are kind of irrelevant over a period of time. So you need to make sure that you're picking the right attributes to feed into the model. Otherwise, the model is going to be like, okay, it'll operate for 1 month, and after that, it's going, then it's not predicting properly, right? Okay. Now, next slide is overwhelming. Okay. Believe it or not, like there's so many options out there right now in terms of who's operating in the ingestion layer, object storage, so many options. Some are open source, some are enterprise licensed, some are just SaaS versions. You name it. Again, if you can memorize all of this, you'll get an extra pizza today. Okay, that's.
I hope you had an AI build a slide for you.
So yeah, that's MLOps end-to-end. There are tools out there that can literally do anything. But here's the thing: just because the tools exist doesn't mean it's right for you. This is very important. A tool like Fivetran would not work in a company like Nielsen for that amount of scale and volume. Okay, so that's why but if you're a medium-sized company and you're processing a few terabytes of data, most solutions will work. So all I'm saying is there's no one shoe fits all solution. It has to be based on how much data you're processing, how frequently you're processing, what your consumption layer looks like, how long is your processing, how much SLA, flexibility you have. Can you run this pipeline for 24 hours, or you have to finish in 3 hours. All these things are extremely important to figure out which solution is valuable, right? For you. So again, tons and tons of solutions out there. And this is not all, by the way. I know I missed a few. I know I missed a few that I don't know. But I did not have enough real estate on the slide to put in more images. Okay. All right. Now, how much time we have, Dana? Okay, we have time. Okay, good. So I'll talk about Snowflake Data Cloud. Earlier I spoke about how the Snowflake is making its own ecosystem wherein like I want to provide tools for processing like Snowpipe and whatnot. I'm also providing tools for machine learning. You can literally build your pipeline within Snowflake itself. You don't have to go out of it, right? So they're trying to make it extremely friendly for all use cases, right? That's exactly what Databricks is doing. Databricks is having their Delta Lake, their lake house for storage and everything. Same concept. Like everyone is like, once you are in, I want to make it so difficult for you to get out, right? So Snowflake, why is it so powerful? Okay. Storage and compute are decoupled. Why is this important concern? Anyone explain? So typically what happens in a traditional data warehouse is I'm limited by the amount of space I have on the server for me to process something, right? Snowflake was a pioneer in this, wherein they said, you know what? Compute is what I need to care about. Your storage, don't worry about it, because storage is actually S3 or something behind the scenes. You need to worry only about compute. Now Redshift joined the bandwagon like 3 years after Snowflake actually came into picture. Redshift also has a compute separate from storage, concept there. There's that type of cluster. Because, when you talk about scalability, right? Should I scale the compute up or should I scale the storage? If you have to do both together, then it becomes a lot more expensive and it's more difficult to manage. That's one of the reasons why Snowflake doesn't need a full-time administrator. There's no concept of a Snowflake administrator. In my company, there's no Snowflake admin. It's a highly self-managed. Massive amount of parallelism, because you can literally have multiple clusters, multiple compute clusters running its own workload without crossing each other, right? Without stepping on each other's toes. You can have I can have my sales pipeline running in one cluster. I can have my finance pipeline running in a different cluster. They don't step on each other's toes. And even within the same cluster, you can define how many nodes you want, basically how many servers you want in that, and you want to scale up or down. Everything is that's where you get maximum massive parallelism. So everything is like easy to manage. Multi-cloud, because you can bring your own cloud. You can have it on AWS, you can have it on Azure, you can have it on Google. Or that's it, right? And even I don't think they have Oracle Cloud, because Oracle and Snowflake are not good friends, right? Data lake plus data warehouse. I think I mentioned it earlier, right? You can use it as a data lake and a data warehouse. It's highly analytics optimized because it's all columnar, so it's easy to query. Make it easy for they call it compute optimized. So I should be able to run massive amount of select statements on it without needing to worry about the amount of time it's taking. But of course, don't write bad query just because you have high compute. Snowflake is going to cost a lot of dollars. Yeah.
It's all at the same time, like it's better to pivot tables. So it's more cheaper to store than compute in Snowflake.
Say that one more. I couldn't hear you.
It's my company. It's already, if we have a query that we repeat like 2 times a day, it's better to have a table and a procedure.
I still couldn't get the question.
He's saying it's cheaper to have a procedure rather than 2 select statements.
Yeah, exactly.
Not really. That doesn't matter because the question is how I talked about orchestrating, right? How you are piecemealing it together. You can have Airflow call a SQL, or it can just fire a stored procedure as well. In Snowflake, stored procedure is essentially like a JavaScript function. I personally don't like the syntax because I have to remember JavaScript code, how to write JavaScript code within Snowflake. Technically, it doesn't matter. The question is how efficient the SQL that you're writing. That's what matters. I once had an engineer that wrote a query that took 6 hours in Snowflake. Now that is called, I don't know what to term that. That costs a lot of money because Snowflake charges based on amount of compute time you're occupying. If you write a bad query, even if you have a large cluster, the cost is going to be like extremely high, right? So it's very important to write efficient SQL. Doesn't matter which platform you're using. Automatic partitioning and clustering. Now, this is where I said no administration is also required, right? Because typically in traditional data warehouse, you need to worry about how to partition their data. What is the partition scheme? Should I partition by year, by day? Should I partition by particular column in the table? Snowflake handles everything. There's a concept called micro partition. Literally, when you insert data, it splits all data, the rows into small partitions of 50 megabytes to 500 megabytes. So whenever I'm querying, it knows exactly which micro partition to go hit. That's why your query results are extremely fast. Okay.
On the rows or columns, so if you're going to really denormalize very flat table, like is it going to chunk it up by columns or is it chunking?
No, it's by rows. It's the groups of rows. That's how it's partitions, right? The good news is automatic partitioning. So I cannot tell Snowflake, here's how I want you to change your partition scheme, because Snowflake is smart enough to do it. Again, probably Snowflake is the only one that does automatic partitioning to the extent that because it's micro partitions and you're looking for a specific chunk of rows, it knows exactly, okay, I need to hit these 10 partitions and bring the data set. It's not, so if you have a 10 billion row table, okay, it's not querying all the 10 billion rows at the same time when you write a select statement. Because it has split already in partitions and it happens close to real time. Upon the data insert, it's actually partitioning it, right? So it knows exactly which micro partition to do. So also it does automatic clustering. So clustering is basically the sorting of data within the partitions. Because only if it's sorted, you know exactly to pull the results the fastest, right? It has to be in a certain order. Now, clustering, sometimes it could be an issue if it's a huge table and you want to, the current clustering scheme doesn't work, the automatic clustering, then you have a say of changing the clustering scheme. So partitioning, you don't have a way to change the partitioning scheme, but clustering, you could change the clustering scheme for certain tables. In fact, we have one of our tables that's growing almost like 300 million rows a month. The thing is the current clustering scheme was not working for us because the query was taking a long time. So we have introduced our own clustering scheme on that because it's a huge table that did not work earlier, right? And then Snowpark. So traditionally, Snowflake, when it was introduced, it was very friendly for SQL developers, people who are very comfortable in SQL. But then you know what? Our other side of data engineers said, you know what? I'm a Python guru. Okay. How do I write Python code in Snowflake? Similarly, Scala. So this is mainly more friendly for big data engineers who are used to they're particularly, it's mainly this, right? Snowflake, hey, you know what? Don't work on Databricks just because you know Spark. I can give you a Spark interface myself, right? I told you, like Snowflake and Databricks are friends, right? So they made it more easy for other people who know other languages like Java, Scala, whatever. They can write, they can process everything in Snowflake in their own language that they are comfortable with. So Snowpark is the UI. They termed it because maybe you got Snowflake plus Spark, something like that. So that's why they came up with the Snowpark. You can use any of the languages that you are familiar with, specifically in the big data space. You can do the coding in Snowflake. ML friendly. So earlier it used to be more like, hey, you have your Jupyter notebooks, you can write your Python code, bring the data, query the data through an interface. Now it's more like, okay, Snowflake provides its own set of ML functions that you can write directly on Snowflake where the data resides, which means the overhead of taking the data somewhere and then processing, running ML models on top of it is reduced. Now because it's literally like you're processing closer to the data. Any questions on Snowflake? Of course, I can spend 3 hours on talking about Snowflake. I just want to give a high level of, why Snowflake is popular.
Yeah, about Snowflake, about Snowflake specifically. The data engineer was better than data in terms of efficiency, divided in Python, when SQL and Snowflake.
Not that I know of, because ultimately it translates that into a SQL, or it's like a data frame, right? Ultimately, you're processing everything in a data frame. The thing is, it's mainly you can bring your own language that you're comfortable with to process data. That's what they're trying to. That's why they're making it more scalable so that they can have more wider audience. Because when Snowflake was originally launched, everyone is like, "Oh, I'm a big data engineer. I'm not comfortable in SQL. So what do I do?" Right? And by the way, all data, and if you're processing data, you have to be comfortable in SQL. That is like no, options. You have to. If you're a data analyst, you need to write SQL. If you're a data scientist, you need to write SQL. Right? But that was the main theory for They want to make it more data engineers friendly, coming from different platforms. Yes.
So the Snowflake has its own library for machine learning.
Yes. Yes, it has its own set of libraries for machine learning. Ultimately, there's also you can also use a lot of native Python libraries directly as well. Right?
So say ML friendly, do you also mean MLOps friendly? Do you have automatic deployment and the applications can consume the outputs of the ML models?
So I've not personally worked on that. I'm assuming it should be MLOps friendly. Again, I can only assume, because the thing is, like, we currently use a data science as a service tool that provides MLOps. It comes along with it, so we're using that. One of the things that Snowflake is claiming is that you can literally run your full full machine learning models here, along with model efficiency loss. You can monitor it and things like that. You're talking about ML monitoring, right? I have not personally played with it, but I can only assume that if I'm providing all these ML capabilities, I should at least give you a monitoring and control as well. I would think so. I have not personally played with it. Any other questions on this? All right. Because I work for SurveyMonkey, please feel free to provide feedback on this session. And for future sessions, anything else you'd like to see, will take you less than a minute.
On your prior slide.
Yes.
You can get that up.
Oh, I'm sorry. Okay.
I'm curious about Snowflake either on AWS or Azure and analytics stacks. Try to play nice with things, whether you're using Tableau or Power BI. Is there easy transferability between like Azure stack, AWS, or
So
for those big and some ecosystem?
because Snowflake is interoperable across multiple clouds, right? Public clouds, whether it's like AWS or Google. The thing about Snowflake is you don't even know. You cannot even see the thing operating. It's all behind the scenes. So the only thing you're telling when you're provisioning Snowflake, you're telling them that, okay, I use AWS in my company across the board, so I want you to provision this in this particular region on AWS. and then it just happens automatically. When I say automatically, all I mean is like, you don't know exactly what S3 buckets are there behind the scenes, because the only thing you see is like your queryable interface and your tables and whatnot, right? What you don't see behind the scenes is like, okay, is it on Azure or AWS or Google Cloud? You don't know, but you just know that it's in AWS because that's what's part of the installation. It's highly interoperable. So that's the reason that they're able to attract customers who are operating multiple cloud systems. In fact, at Nielsen, we had one part of company that was using Azure and they were using Snowflake. We have another part of the company that was using AWS and using Redshift.
So in that like shared stack in like Azure and AWS, what about like app-to-app sharing? Is there any barriers to that?
So,
Or is it
yeah, so Snowflake itself has this concept called data sharing, right? So Snowflake data share is again interoperable. It doesn't matter where that original Snowflake resides, whether it's AWS or Azure, it doesn't matter. They only give you interface to the actual Snowflake data itself. It doesn't matter which cloud system that it's hosted in, right? So that's why I said it's multi-cluster and multi-cloud, because it's highly interoperable, right? So you could have a company that's using both systems, and you can have one in one on the other. You can have Airflow running on Azure, and you can have Snowflake running on AWS. It's going to work. Yes.
Are you familiar with Data Hub by LinkedIn? And if so, what's your opinion of it?
On what? Sorry.
It's called Data Hub by LinkedIn. It's an open source. They store metadata.
Data Hub, I'm not familiar. I'm sure it's one of those
Yeah.
things in my tech stack. I'm not familiar personally.
All right, let's give three. Thanks.
Oh, thank you so much.
Thank you.